real smooth.
Do they have a smoothie named Rocky Road? That'd be kind of funny. Rocky Road smooth. Never mind. It's called irony. Irony. Okay. Called what? Yeah. Is it blue? Okay. Is this exponential growth or decay? Is this... I got to vote for decay. Why do we think it's decay? Because we know that the growth factor is between 0 and 1. That is true. What's the y-intercept? Just curious if you know the y-intercept. You would find that by looking at the number in front of the parentheses. That's a 1. Okay, so I'm looking for a graph of exponential decay. Here, we'll label them A, B, C, D just for these variables, because sometimes it's easier to see them that way. Which one of those are we dealing with? That's what they told me. Exponential decay. C looks like a, I know you didn't say C, but C looks like a radical function, so that is definitely a bad choice. B looks like exponential growth. Okay. D is the only one there that is exponential decay. I am curious about something. I know this question doesn't ask, what is the domain of the function? What is the domain? Push it all down on the x-axis and tell me how much of the x-axis would be covered. What is the domain? Slide that whole thing down on the x-axis. What do you think? Push it on. 1? Do you think the only number in the universe on that graph is a 1? I think there are a lot more values than that. I know, but I need you to think. And you weren't engaged. Slide every point on that graph straight down on the x-axis and tell me how much of the x-axis would be covered. Just keep in mind, this thing is going to continue up and up and up. Infinity. Yes, so let's describe that a little bit differently, but you're on the right track. How would you say infinity, but give me the all real numbers? Yep, you could say that. You could say all reals. You could use the all real number sign. Okay, which will eventually... You know what? I should just get a henna tattoo since I'm scared of the other kind. No, I'll put it right here. All real number sign right here. What? I don't like the idea because I think I would psychologically, and plus it would be permanent, and then, you know, when I'm 85, it would look not so real. Yes, it's exponential growth, yes. Yeah, but then eventually it'll be like exponential decay. Never mind. On my neck? What? I already got one of those quadratic formulas. Okay, now. What about the range? What about the range? Push it all on the y-axis. How much of the y-axis gets covered? Push it all together on the y-axis. How much of it gets covered? Push it. Push it. Push it. Come on, you engage. Push it together. What do you get? How much of the y-axis get covered? All of it. No. If you're not looking at that if you think all real numbers. Come on, push the whole thing. Get off that thing. Come on, pay attention. Push it all together. How much? Okay. Come
I like that. I like that. Stay with me instead of pointing at somebody else. Learn something. So, it's a weird name for your parents to give you, but okay. Now, if you push the whole thing together, so all of these points are coming over, and then every one of these is coming over. You'd never get any of these negatives, right? Oh, so all real numbers. No. All real numbers would include everything. She said only the positives. And I said I'd like that. Okay, would I include 0? Because asymptote, right? You don't touch the asymptote. We're going to say y is what? Greater than? Y is greater than 1. Well, that means y is greater than what? 1. 0, sorry. Remember, the asymptote is at 0 here. And we're going from there on up. That's what goes with what you said. Positive numbers. You've got to interpret that and put it together yourself. Y is greater than 0. Okay. We can clearly see on question 2 that we're dealing with an exponential growth function. Right? Okay. The question becomes, which way is this graph being moved? Alright? Now, I'm going to get rid of choice B. Why would choice B? It has not been changed at all. And if this is true, then you would have to get closer and closer and closer and closer to the x-axis. Y equals 0 would have to be the asymptote of that graph, and it does not look like it's getting closer and closer to that line. Doesn't it look like it's stopping? What line does it look like it's getting closer to? Doesn't it look like it's getting close to this line, which is y equals 2? Which means what happened to the graph? It was pushed up 2 units. So we need to look at our answer choices and find an answer choice that says that the whole graph got moved up 2. It is choice C because the addition is on the outside of the function. And we talked about how if it is with the x, like letter choice A, then we are either moving left or right. Do you know which way you're moving on letter choice A? Is that left or right 2 units? It is left 2 units because we said that when you are changing the x, it goes against your common sense. When you are changing the y, it matches your common sense. You need to write that down again. It's not going to matter whether it's a radical function or an exponential function or a parabola. All of them get shifted the same way. Okay? Think the next one's D? Okay. So, on question 3 here, why do I think A and B are ridiculous options? Why do I think A and B are ridiculous options? If they were negative, they would have been flipped over the x-axis. So these would be flipped. Flipped over the x-axis, okay? But they're not. So those are bad choices. So do you think this picture looks like growth or decay? This is going down, 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 down as you go to the right, okay? So this is exponential decay. Which one of those functions matches exponential decay? D. It is getting lower and lower. It's getting cut in half. What's the domain of this function? What's the domain of this function?
all reals. If you pushed everything down on the x-axis, you'd cover the entire x-axis. What about the range? Y is greater than 0. That's right, because if you pushed it all up against the y-axis, you'd have everything above 0. Okay, now you might have to look at mine with the blue and the red. The original function f will be in red. And for you, that would be a lighter color on the black and white copy. And the darker one would be the blue one. How do I know right now that A and D are bad choices? Yes, these are exponential growth, and you can clearly see A and D have decay in them. So we really only have two choices here. Right now, what you think the choice selection should be, based upon what you think you see in the function. Decide what letter G is doing to the graph. Is it moving? Which way is it moving? And then pick a graph that moves the red one to the blue one the correct way. So that's up to the next one. Okay, I had, what's the answer choice? C is the correct answer. If we take a look at the function, we can see that this point right here got moved, this point right here got moved over to the left 2 spaces. Okay, so we are talking left 2. Now, I know that this, what I'm about to write, is not something you need to write down, but just to see if this makes sense. 3 to the x plus 2 could be written 3 to the x times 3 to the second. 3 to the x times 3 to the second. I know I could do that because we taught you in Algebra 1 that multiplying like bases, we add the exponents, which we have reviewed recently, especially when we were doing the fractional exponents. So, my question to you is, what is 3 squared? That's 9. So another way to write this would have been 9 times 3 to the x. Now, what is so special about the number 9 according to the graph? That would be your y-intercept, right? Okay. Let me zoom in and take a look at this graph. You can see right up there at 9, it's crossing. It looks slightly off, but it's meant to go through at 9. So when you slid the whole graph over 2 units to the left, that matches what you were talking about. Now, no, I'm not expecting you to write that down the way I just did, but all right, go to question 5. Why are A and C bad choices? Why are A and C bad choices? They've got decay in them. They've got decay in them. You really only have 2 choices, B or D are the only 2. So look at the function, decide which way it's moving. It has to go from the red to the blue. The lighter one to the darker one. Okay, which one is it? B. It is choice B. It is choice B. The red one got shifted up 1 unit. Test over this, we got to get through section 3 first, and then we'll have a test. So could be the end of this week. We can have our 1 to 3 test this week, and then you guys will work on the material 4, 5, and 6 by video. Since I'll be with you next Monday, but not Tuesday, Wednesday, or Thursday. Why don't you shift gears, man, when you're going up that hill? So I'll be heading down for my son's graduation for basics. So I'll be gone the Tuesday, Wednesday, Thursday. Say that again. I don't think he's going to be done with it until he fulfills his contract. So, from basic training, yes. And he's got his AIT school. He'll come back here and do his job. Okay. So, why is choice A a bad one? It's got exponential decay in it, but that's the only one. So now you have B, C, and D you need to choose from. You need to make a decision on what's going on with question 6. Maybe I should zoom in on those 3 choices since those are the only ones. What is the plus one zone? On the outside it says down. So it's not right. Yeah. Yes, right. You cannot be yes. These are both rows. So you can cast the rows up. That's why I chose you for this. Put the down and put days. But none of the other choices have days. Okay, which answer choice did we pick? It is choice D. What does the plus 1 mean? Left 1. Stay with me. And the minus 1? That is down 1. So we were looking for something that went left 1 and down 1. Okay, now focus your attention on the blue one. Sorry, the blue one. After we moved it left and down, let's just focus our attention on the blue one, the G function. Okay, I want to know what you think the domain and the range are of the G function. Just look at that blue one. Think about smashing it all down on the x-axis, so some points are coming up, some points are coming down. How much of the x-axis would get covered? Forever and ever and ever. All middle numbers. Use the symbol, use the phrase, I don't care. If you're really into
do interval notation and you want to write negative infinity to infinity, that's fine too.
Are you telling me that no matter whether it's exponential growth or decay, or how you shift it, left, right, up, down, that you're always getting a domain of all real numbers? That's true, folks. The only thing that's changing is the range. So what's your range on this? Well, y is less than 0. It just doesn't keep going down forever and ever and ever. So I don't think I can agree with less than. But look at it just before you look at it. All right. So push the whole thing, right? Action a little bit. All right. So putting all these points right here, be coming over to the y-axis. Okay. All of these points forever and ever, up. Yes. Greater than 1. Actually greater than, you were close. Unless I misheard you. Great. Well, greater than 1 means that you're starting here and going up. I want greater than what? Negative 1. Greater than negative 1. That's what we should have been doing. Why is it not equal to? Why is it not equal to negative 1? Because that's the asymptote of the function and you don't touch the asymptote. Yes, Lord. Okay, my name, well, I don't think I've ever been called that. Okay. And we shall continue more tomorrow.